Hi, good morning everyone. Today I would like to share with you another example on non-homogeneous linear differential equation. Okay. Alright, okay, let's look at example 3.7. Find the general solution of the following non-homogeneous system of first order LDE. You have the question like y1 prime equal to 2y1 minus 4y2 plus 2x squared plus 10x, and y2 prime equal to y1 minus 3y2 plus x squared plus 9x plus 3. Okay, so we use the method of undetermined coefficient. And this is the only method you will study for this one, the method of undetermined coefficient. So do you still remember what is the first step in order to find the non-homogeneous general solution? Okay, YC. Yes, correct. Okay, so first of all, you need to find your YC. Okay, YC. So first of all, you need to know what is y prime equal to ay plus g. So this is quite common to you, right? So from the differential equation, you need to confirm to transfer this differential equation into ay plus g. So from here, you know that this is 2, -4, 1, -3. So this part is the g. Okay, so you have 2, -4, 1, -3 plus 2x squared plus 10x, and then x squared plus 9x plus 3. Then second is to find the eigenvalue and eigenvector. So from the A, so you have 2 minus lambda, -4, 1, -3 minus lambda. So you have 2 minus lambda and then multiply with -3 minus lambda, minus with -4 multiply with 1. Then equals 0. So you multiply in, you have -6 minus 2 lambda plus 3 lambda plus lambda square plus 4 equals 0. So when you simplify, you have lambda square plus lambda plus minus 2 equals 0. So you can factorize it. So after factorize, you get lambda equal to 1 and lambda equal to -2. So this is the eigenvalue. You need to find the eigenvector again. So for lambda equal to so lambda equal to +1. So you have 2 minus 1, -4, 1, -3, -1. So you have 2 minus 1 is 1. So this one you get x minus 4y equals 0 and x minus 4y again equals 0. So you assume the x is equal to s, you get s minus 4y equals 0 and y equal to 1 over 4s. Okay, so your eigenvector is xy, so you get 1 and 1 over 4. Okay, this is for lambda equal to 1. What about for lambda equal to 2? -2. Okay, so you substitute the value of lambda. have x and y. So you have 4x minus 4y equal to 0. Okay, again you assume x is equal to s, so you have x minus y equal to 0, y equal to s. So your eigenvector again is, what is the value? Yes, 1 and 1. So the next step is to check your eigenvector is linearly independent or not. So you have 1, 1. So you write down 1 and 1. Another one is 1 and 1 over 4. 1 and 1 over 4. Okay, you get 1 over 4 minus 1. This is equal to negative 3 over 4, which is not equal to 0. We name it as a linearly independent. Then we can write down the general solution for YC. So YC equal to C1, 1 and 1, for the lambda equal to negative 2, plus C2 for the vector is, eigenvector is 1, or 1 and 1 over 4 for lambda equal to 1. So this is your YC. Okay. For non-homogeneous, we need to find the YP. So part 2 is to find YP for non-homogeneous. Okay, so first of all, you need to assume the YP. Okay, find the YP. So how to find the YP? You need to know what is the G value. G is equal to 2x squared plus 10x, and then x squared plus 9x plus 3. Okay, so this is your G value. Again, from here, you can refer to the formula or the table in page 79. Okay, page 79 is about this one. You can assume the YP based on the G. So in this case, you have the G is 2x squared plus 10x. So 2x squared. So this is the polynomial x squared. X squared, 2x squared plus 10x. So this is referred to this one. So this is case number 1, and your assumed YP should be the third one. U1x squared plus V1x plus W1. Okay, now, so you assume YP is equal to U1, U2, x squared plus V1, V2, x plus W1, W2. Okay, so this is from the page 79. Now you check. Now you have to assume the YP. After you assume the YP, then you check whether this YP is same as the YC or not. Okay, so this is your YC. Okay, this is your YC, and this is your YP. You check whether it's the same. Yeah, it's not the same. Okay, correct? It's correct. Okay, so YP is not the same with YC. Okay, so it's not the same means that this is your latest YP. Then second step is to find the YP prime. So from the YP, you obtain YP prime. Okay, can you tell me what is the YP prime here? Okay, you differentiate about this one. You get, what do you get? 2u1, 2u2, x. Okay, correct. Plus, this is v1, v2, and this one, the w is nothing. And the third one is compare YP prime and Y prime. So YP prime equal to Y prime which is equal to ay plus g. So which is equal to yp prime is 2u1 2u2 x plus v1 v2 equal to a is 2 negative 4 1 negative 3, and then u1 u2 x square plus v1 v2 x plus w1 w2 plus g. G is 2x squared plus 10x x squared plus 9x plus 3. Okay. So now you can multiply in. Means that you need to solve this part. You have this one, right? You multiply in this part. So you have 2u1 minus 4u2 u1 minus 3u2. So this is for the x squared plus 2v1 minus 4v2, and then v1 minus 3v2 x, then plus with what? Plus with 2, okay, this one, w, 2w1 minus 4w2, and then w1 minus 3w2. Plus with 2x squared plus 10x, and then x squared plus 9x plus 3. Okay, so you can compare the coefficient. Okay, well, let's simplify first. Let's simplify. Collect all the x or x squared. Okay, so from the left you have 2u1 2u2 for the x, and then plus v1 v2, and then for the right hand side you also have the, okay, you have the x squared, so you need to collect all this. 2u1 minus 4u2 plus 2, and then u1 minus 3u2 plus 1 x squared, and then plus with collect the coefficient of x. So you have 2v1 minus 4v2 plus 10. Okay, for the power of, for the x. v1 minus 3v2 plus 9, and then plus with 2w1 minus 4w2, w1 minus 3w2 plus 3. Okay, now by equating coefficient, compare x squared. So if you compare x squared, this refer to here. Okay, you have x squared, but left hand side don't have. So when you don't have, you put 0, 0. And the right hand side is 2u1 minus 4u2 plus 2. And then you have u1 minus 3u2 plus 1. Okay, from here you can have two equations. That is 2u1 minus 4u2 equal to negative 2. So this is equation number 1. And then equation number 2 is u1 minus 3u2. Okay, I just assume u1 is equal to what? Okay, u1 equal to negative 1 plus 3u2. Okay, so this is equation 2. Now let's insert the equation 2 into equation 1, and then you get 2u1. So you have negative 1 plus 3u2 minus 4u2 equal to negative 2. So you have negative 2 minus 6u2 minus 4u2 equal to negative 2. So you have negative 10 u2 equal to negative 2 plus 2 is 0, so it's 0. So u2 is equal to 0. And then u1 is negative 1 plus 3u2, which is referred to here. u1 is negative 1 plus 3u2. So u2 can 0, so you have negative 1 only. So your u1 equal to negative 1, u2 equal to 0. So this is you obtain the u1 and u2 when you compare the x squared. So now let's compare with x. When compare with x, what do you have? This one and this one. I think I missed out this one, x. So you have 2u1, 2u2 equal to 2v1 minus 4v2 plus 10. And then v1 minus 3v2 plus 9. And then you substitute the value for u1 equal to negative 1 and u2 equal to 0, which is you obtained just now. Alright. So negative 10, negative 2. Why negative 10 means that the 10 here you bring to the left hand side. Okay? And then u1 is negative 1, so you substitute the value of u1. So negative 10, negative 2 equal to 2v1 minus 4v2. And then this one is 290. So negative a equal to v1 minus 3v2. So v1 equal to 3v2 minus 9. So this is equation number 3. Just now is 5. Oh, okay. So 4, okay, 3. So insert the equation 4 to equation 3. Insert the equation 3 to equation 4. You obtain negative 12 equal to 2, 3v2 minus 9 minus 4v2. So this is equal to 6v2 minus 18 minus 4v2. Again, v2 is equal to negative 12 plus 18 divided by 2. So you get 3. Then v1 is equal to 3v2 minus 9. Then you substitute the value of 3. You get 0. So from here you know that v1 equal to 3, v2 equal to, v1 equal to 0, v2 equal to 3. Again, you compare. Next is to compare the x power of 0. So you have v1, v2, 2w1 minus 4w2. Okay. So from here you know that v1 is 0, v2 is 3. So you substitute the value. And this is what you get. Okay, so for the first line. Second line is V2 is 3. Second equation, B2 is equal to 3 equal to W1 minus 3 W2 plus 3. Okay, so W1 you get 3 W2. So this is equation number 5. Okay, this one equation number 6. Again, equation number 5 you insert into equation number 6. And then what do you get? So you have 6 minus 2 minus 4, you get positive 2. So when W2 equal to 0, W1 is equal to 3W2, which is also equal to 0. So now W1 equal to 0 and W2 is also equal to 0. So your YP is negative 1, 0 for the x power of 2. And then plus 0 and 3 power of x. Multiply with x. So this is the YP value. So what is next? The last part, it will be the general solution. For the non-homogeneous, after you find the YP and YC, you need to combine together. So Y equal to YC plus YP. So you know that YC is C1, 1, 1, exponent negative 2x, plus C2, 1, 1 over 4, exponent x, and then plus with YP. Okay, YP, so this one. Okay, since there's a 0, so let's simplify. You can have a negative x squared plus 0, and then you get negative x squared, and 0 plus 3x, so you get 3x here. Okay? So you have negative x squared and 3x. Alright, so this is the general solution for the non-homogeneous, in which the y is equal to yc plus yp. Alright, hope you can understand, and thank you for watching.